next is the strain comparative method. So in this, it is the method which is been basically it is a theory which is applicable for the structural concrete section, whether the reinforcement or the PSC section. Generally, there may be made some assumptions here. In this, what are the assumption which we made is the stress whatever the which has been distribution in the compression zone of the concrete can be defined by means of the coefficient which is applied to the characteristics of the compressive strength and average compressive strength. In the center, compression can be at anywhere in middle, it can be assessed. So next is the distribution of the concrete strain will be linear. So in the plane section, if you take a normal to the axis, the remain whatever the bending plane, it will remain same. So the resistance of the concrete in the tension, it will be neglected. And the next last most assumption is the maximum the compressive strain in the concrete at a failure reaches the particular value. So that is the four assumptions. So in this, the flexural compressive stress in the compressive zone is closely follows the stress strain curve of the concrete. So where the properties of the concrete in the stress block can be expressed in the terms of the characteristics ratio. So this is the very important, the properties of the concrete stress block, whatever the stress block properties, it will be characteristics in the ratios of K1 and K2. And much research can be carried out in the study of the characteristics of the stress block. In this particular test, so whatever it is there, it has been considered the influence on the American and the indirectly on the British and the Indian standard codes. So I will show it in the figure. Here the value of the K1 varies from 0.5 and 0.7, 0.5 to 0.7, and K2 varies from 0.42 to 0.47. For the compressive strength varies from 60 to 20 Newton per mm, sorry, 20 Newton per mm square. So here you can see here in this figure a block of the breadth B and depth D, effective depth D, APS is the area of the steel. You can see here the second in the figure 7.2 stress strain distribution of failure. The strain eta c epsilon cu is the strain in the compression, and FCU minus FCE, that is the difference in the compression and the tensile strain. So the parabolic, the another part in the extreme right corner, it is the stress strain diagram of the at the failure, where the figure it is been idealized, where K1 FCK at the top, it will be the K1 and FCK, and K2 X, that is the distance to the compressive force. So that is what the stress strain distribution. So a line is been drawn, an average. So whatever the cut portions are there, so the extra negative, so that will be equivalent. So if you take that one as a rectangular, so whatever the parabolic portions are there, that is been idealized into a rectangular section. So in this figure, you can see here there is the in this graph characteristic graph, where this is the very important to take the value of K1 and K2. See here, this is the value of K1 and K2 with respect to the characteristics of the K1 and K2. Here this is the x-axis is the cube strength of the concrete. Okay, so this is the idealization. So whatever the negative, whatever here the parabolic is there, so that has been idealized, that has been made it into a straight line. Okay, so whatever the negative portion here, negative portion it is in there, so that part here extra positive portion is there now, here this portion, so that area will be cutted and pasted here and here. So that will be equivalent or approximately to the rectangle section. Okay, so here parabolic, whatever this parabolic section is there, it has been made it as a rectangular section. Okay. mm, so like that, the value of k1 and k2 will be taken with respect of epsilon cu. These three values will be taken. So here the y-axis, here it will be taken as k1 and k2 characteristics. Hmm, these are the characteristic ratios k1 and k2. Here the it will be epsilon cu. Okay, so here character strain due to the compressive stress. Okay, so these are with respect to this graph being plotted. So you got the three characteristics of k2, k1 and sorry epsilon cu and k1 and k2. So with respect to this characteristic or the cube strength of the concrete to the characteristics ratio, you have to see the value of k1 and k2. Okay, this value has to be seen. So like this you have to check the values. Well, problem solving the problem, I will tell you how to find out this k1, k2 and epsilon cu with respect to cube strength and the characteristics ratios.